Good day, students and viewers. Good day, students and viewers. You are welcome to the studios of Maths X. Today, we are still on fractions, decimals, and percentages. Previously on our video, we discussed the third mathematical operation involving fractions, and that is division of fractions. I talked to you about similarities between division of fractions and multiplication of fractions. In that video, I also showed you how to multiply, to divide using some examples involving at least three types of fractions. In that particular video, I also ended by, or concluded rather, by introducing us to what decimals are, definition of decimals, and place values of numbers regarding decimals. In today's video, we will surely consolidate on what we had learned previously in our video. And we're going to start with types of decimals. Happy viewing. For types of decimals, in mathematics, we have four types of decimals, my dear students and viewers. And the first type of decimal is the terminating decimal numbers. So the first type of decimal I want us to talk about are the terminating decimal numbers. For the terminating decimal numbers, they have a finite number of digits after the decimal point. That's what makes them unique. They have a finite number of digits after the decimal point. For instance, if like this number here, I wrote earlier 26.625. Maybe also 781.25. So they have a finite number of digits after the decimal point. These numbers are rational numbers. These numbers can be written in ratio form. Another name for terminating decimal numbers is the exact, they call them exact decimals. That's another name for the terminating decimal numbers. They are called exact decimals. Like I said earlier, they are rational. They can be written in ratio forms. These numbers can be written as decimals, as mixed fractions. Like I said, they can be written as in ratio forms. So this can be written as 26 whole number 5/8, and also 781 whole number 1/4. So for terminating decimal numbers, like I said earlier, they have a finite number of digits after the decimal point. They are also called, another name for them is exact decimals. They can be written in ratio forms, meaning that they can be written as fractions. I just demonstrated that to you here. They can be written as mixed fractions. They can be written as ratios. They are rational numbers. Speaking of numbers being rational, there will be a link in this video that takes you to our video on sorts. You need to watch that first video on sorts because part of what I'm talking about now is already in that video. So to foster understanding, I would be glad, my dear students and viewers, if you would check my first video on sorts, and not just the first video. There are about 4 videos on sorts. You would go through them and then clear every doubt that you have regarding sorts. Our second type of decimal number is the non-terminating decimal numbers. My dear students, for the non-terminating decimal numbers, these are decimal numbers that have an infinite number of digits after the decimal point. Still saying it again. These are decimal numbers that have an infinite number of digits after the decimal point, meaning that the digits after the decimal point never stops. It just runs till infinity. I discussed some of these things earlier. Like I said, for instance, I have a number like 78.7213 dot 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 dot, dot, of course, till infinity. Also, I could talk about, since I used 26 there, 26.322314 dot 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 dot, dot till infinity. So the digits after the decimal point is endless. It just keeps on going till infinity. So that is the non-terminating decimal number. Now, for this non-terminating type of decimal number, it also has two types. For I'll need some space. The first type being the non-terminating, non-terminating and recurring decimal numbers. So for this type of decimal, the non-terminating and recurring decimal numbers, the digits after the decimal point are endless. They tend to infinity, but they tend to repeat. They tend to repeat. And what am I saying? Let's look at a number like 10.272727 dot 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 till infinity. Just like I had explained this in our video on sorts, this can be written as 10.27 with a slash on top. When you do this, you just told your examiner or anybody assessing you that this number is a non-terminating and a recurring decimal number. What you've done here is that you've just told your examiner or your teacher that this number just keeps on going on. So this is a non-terminating and recurring decimal number. These kinds of numbers are rational numbers, and they can be written in ratio form. Let's look at the second type of non-terminating decimals. So there is the non-terminating and non-recurring decimal numbers. These are also non-terminating decimals, but in this case, it has an infinite number of digits after the decimal point, as in they are endless. But unlike this recurring type, the digits follow no specific pattern. It just keeps on running. It changes. It doesn't repeat like I tried to show you here. Let's look at an example like maybe 42.781621 dot 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 till infinity. So they follow no specific pattern. The numbers are just there. When you divide, maybe another one. I'm looking at 1.7. What's with me and sevens? 1.72163.891 dot 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 till infinity. Now this type, like I told you, the numbers after the decimal point are endless. They run to it till infinity, but they follow no pattern. They are just there. These kind of numbers are irrational, and they cannot be expressed as what? Fractions. So for the non-terminating decimal numbers, we have two types, which is the non-terminating and recurring decimal numbers and the non-terminating and non-recurring decimal numbers. Do take note of that. For the third type of decimal numbers, the third type of decimal numbers are called like decimals. Let's put it down. Like decimals. Like decimal numbers. What are like decimals? Like decimals is a case where two or more decimal numbers have the same number of digits after the decimal point. What do I mean? Maybe I have 56.70, maybe I have 21.22, maybe I have 0.91. If you check out these numbers, they have the same number of digits after the decimal point. So these digits, the whole three of them are like decimals. The fourth type of decimal I want us to talk about, my dear students, of course, if there is a like, there should be an unlike. So there is also unlike decimal numbers. This is also a case where two or more decimal numbers do not have the same number of digits after the decimal point. And that is a very quick show. That'll be 1.273. Maybe another one, 29.1, or maybe a third one, okay, 0.1634 dot. This one is non-terminating, not a non-terminating type. So these three decimal numbers are unlike. These three decimal numbers are like. So my dear students and viewers, those are the four types of decimal numbers we have in mathematics. I hope you are thoroughly enlightened. So for our first mathematical operation involving decimal numbers, we are going to go into addition and subtraction. The first thing I want to tell my students and viewers is that when it comes to addition and subtraction, ensure that ensure that you align the numbers based on their place values with the decimal point, using the decimal point, I mean to say. So for instance, like our example here, our first example here, I'm saying add the following decimals. That's 2.872, 6.261, 25.105, and 102.3. To add this, you're going to align the numbers based on their place values using the decimal points. That's one thing with addition and subtraction. It's pretty very simple. I know most of my students and viewers, you are aware of this particular operation, but just to clear some doubts, it's good we get into it. No assumptions. Okay, so for this first example, the numbers are, for the A part, the numbers are, I'm seeing here 2.872, 6.261, then 25.105, and 102.3. Like I told you earlier, of course, indicate that it's an addition. Like I told you, arrange the numbers based on their place values using the decimal point, aligning them with the decimal point. So this kind of addition, 2 plus 1, 3, 3 plus 5 is an 8, so that's your 8. 7 plus 6 is 13, so you have a 3 and you carry a 1. So you have 8 plus 2 is 10, 10 plus 1 is 11, 11 plus 3 is 14, plus the 1 here, you have a 15, so you have a 5 carry 1, aligned, put your decimal point because that's where the decimal point is. So you have a 1 here. So you have 2 plus 6, 8, 8 plus 5, 13, 13 plus 2, 15, plus that one, 16. So you have a 6 and you have your 1 here and you have your 3 here and your 1. So altogether, the sum of this addition of 2.872 plus 6.261, 25.105, and 102.3 is 136.538. Notice the way I'm calling it. I'm calling it 538. I'm not calling it 538 because this is a tenth, a hundredth, and a thousandth. I talked about this in our previous videos. If you have not seen those videos, you would endeavor to watch them. I'll need space to write up this particular example, the B part up here, which is simplify 2.7131 minus 1.141 minus 1.052 plus 4.2. That's what it is here, 4.2. For this kind of addition, you need to separate the ones with the minus and the ones with the plus, and then do a sum addition or subtraction. So let's see what I'm going to do next. I'll need some space, my dear students and viewers. So like I said earlier, you will separate the decimals with the minus sign from the ones with the plus sign, because 2.7131 has a plus sign on it. It's how numbers are arranged in mathematics. So I'm going to have 2.7131 plus 4.2 minus 1.141 minus 1.052. So for the addition ends, to be clear, we're going to have 2.7131 plus 4.2. We have a 1, a 3, a 1, a 9, and a 6. Then for the other ends, we have minus 1.141 minus 1.1052. Excuse me. 1.052. I missed it. So we have 3, we have a 9, a 1.2. So this is minus. So we have 6.9131 minus 2.193. So here we go for the last part of it. 6.9131 minus 2.193. So in subtraction, this will be a 1. 3 minus 3 is a 0. 1 minus 9 cannot. Borrow 1 from this 9 here. And we have 8. So we have 11 here. So 11 minus 9 is a 2. Then we had 8 remaining here. So 8 minus 1 is 7. Then, of course, 4. There's a point here. 6 minus 2 is a 4. That's the 4 I said earlier. I guess I moved a little fast. So, my dear students and viewers, I trust the addition and subtraction of decimals should not really make you sweat. In our next video, we will talk about multiplication and division involving decimals. Till we meet again, my dear students, keep on watching the videos of my like, subscribe, and share. And as you do so, you're going to learn a lot.